Good. So here, so this is the formula. N minus mu divided by the standard error. So what are these things mean here? If you look at, this is the formula. We have to obtain the z-score because we need to find out whether the z-score falls between these two areas. If it doesn't, then we reject it. So here M is, oops, sample mean, mu population mean, sigma M standard error. So all these three things we need to have, but we don't have this one, right? All we have is the value for the sample size, we have that. We have the standard error for, the standard deviation from the population, sigma, we have that. So how do we find out the standard error? How do we calculate the standard error? What was the formula we used last time to calculate the standard error? In the previous chapter, we calculated the standard error. Standard deviation divided by square root of n. N, square root of n. So the standard deviation divided by square root of n. The standard deviation given to us is there, is 8. N is lowercase n, that's a sample size, and that is 100. Equal 8 divided by 10, that is 0.8, and that is our standard error. How about these two? We already have these. Sample mean is 70. Population mean is 60. Standard error, we just calculated those. Now all we need to plug in those numbers in this formula. So we'll write Z of 10, ZOBT equal 70 minus 60 divided by 0.8 equal 10 divided by 0.8. How much is it? 12.5. Am I right? No. 12.5. So this is the value of the Z. Now, if you look at this with this graph here with the normal curve, since we are using alpha equal 0.05 and we calculated the Z as 12.5, what do you decide? Are you going to hold on to it or you are going to reject it? Reject the null hypothesis. How do you make that decision? It's very simple. You look at the value of the Z of 10 and look at the values under the normal curve and see whether these values fall within that, within these two. If not, then you reject the null hypothesis. So it's definitely much higher than this one, because even if you look at the right side, it goes up to 1.96, and this is 12.5. So we reject the null hypothesis. Another thing we need to look at, if you look at page number 115 and 116. If you look at page number 115 and 116, we need, this one is important, effect size of a z-test. That means if we are saying, okay, before we get into that, based on the z obtained, we are definitely going to say that we reject the null hypothesis, because that value is definitely much higher than these values here. So we reject the null hypothesis. So what if we are rejecting null hypothesis, that means implicitly we are accepting, we don't say it. Practically speaking, if we reject these, that means implicitly you are accepting it. If you are accepting it, then what will be your answer to that question, whether the special tutoring had any effect or not? What would be your answer? This is rejected. The question was, since this maths, the average of the test score for these 100 students went up to 70 from 60 from the population, and which was because of this special tutoring, we rejected this null hypothesis. The question was, did that special tutoring make any effect on these people? And that's why we came up with this alternate hypothesis that if the special tutoring is effective, then this population mean should not be equal to 60. It should be more than 60. That's why we based this null hypothesis on. So we rejected this null hypothesis. Sorry, this is the alternate one. So we rejected this one. That means implicitly we are accepting the fact that it should not be 60. It should be something more than 60. If it is more than 60, then what will be your conclusion? What kind of effect that special tutoring has? Is the mean going to go up because of the special tutoring, or is going to go down? There is no question of going down, because the only thing it can do is it can go up. That means the special tutoring had some effect on these 100 individuals. See the statement I made, the special tutoring had some effect on these people. How much of an effect the special tutoring had? Was it a, if you look at this page number 116 here, we can describe that effect in terms of three things: either a small effect, or a medium effect, or a large effect. These are the three things we have on page number 116. So we can talk about that effect only in terms of these three. So before we can mention, whether it's a small effect or medium or large, we have to calculate something called Cohen's d, and that really indicates the size of the effect.